in this session, after years of being a Java developer, I've been exploring, along with, I'm sure, many other people, the JavaScript landscape over the past years. And in this session, I want to share some tips and tricks, some useful libraries, especially when we're talking about enterprise applications, so business applications, as opposed to toys and games and prototypes and so on. And the question really is JavaScript suitable for that environment, for larger applications, for applications that need to survive over several years, that have business requirements and so on. So that's kind of the area I would like to explore. I'm from Amsterdam, and you might have seen this, or at least in the Netherlands, most people have seen this. This is the picture that went viral about last year. So for those who probably, I'm hoping everyone knows, this is one of the most famous Rembrandt paintings. It's one of the main museums in Amsterdam. And you see a bunch of kids in the front, all on their mobile phones. And of course, the initial reaction was kind of along these lines, that this is a metaphor for our age, the distracted society, the end of the world, Facebook beat Rembrandt, and there was a lot of consternation and concern, and not quite questions to the Prime Minister at the Dutch version of Question Time, but clearly there was something going on, and this was being tweeted everywhere. And it turned out that actually what they were doing is they were using a museum app. And they had just been sitting there, that's the exact same group, they'd been sitting looking at those paintings and being told all about them, and they were researching those paintings. And so, you could look at the world like this, or you could look at the world like this. But I think I'm more positively inclined, and this increasingly mobile world, this world where the browser platform is everywhere, is one I think that we should simply embrace, and there's a lot to be gained from it. This platform is the one that I really want to talk about, without necessarily promoting it. The browser platform kind of explore that space, and really as a front end, as a UI container. The back end could be anything we like, and we like Java, I imagine. I like Java. So the back end of the story could be very well be Java. But I'm really talking about the front end of these applications. And because the browser is on all the devices, all the screens of your life, it makes sense to explore what one can do with that in real enterprise applications. So I come from Oracle. We've been exploring that particular platform a lot too, and I'll share a little bit about that as we go along. I don't want to surprise anyone with any of the building blocks as we go along. I'll just tell you what they are right from the start. We'll talk about the hype. We'll talk about HTML5. We'll look at CSS, what it offers, what it doesn't offer. We'll look at different approaches we can take to looking at the various libraries that are out there and how to integrate them. Look at modularity to the extent that it is there in the JavaScript ecosystem. We'll talk about various abstractions over the base technologies. We'll look at the volatility of the ecosystem. We'll find out what the mysterious wanta means as opposed to wara. And look at some corporate frameworks. And at the end, we might even look at JavaScript as assembly language and what the consequences of that approach to JavaScript might be. So it's a lot to cover, and there will be demos in between, and hopefully we'll fit it all in the time that we have. I might end up going really fast at the end to cover the 10 tips, but hopefully I'll be quite fast at the start as well. So the first tip I would say is resist the hype. And there are loads of applications that are completely not suited for this browser platform as a UI container. And everyone is looking at this big pile of cookies and wants some of it, wants to integrate into this world because of the easy access that you have to mobile devices and to tablets and so on. But it's definitely not for everyone. Take, for example, the use case of an air traffic control system. I can tell you there will never be a time when there will be air traffic controllers using mobile devices to land planes. And if that ever happens, that's the end of my my world travel for good. Because there is a segment of applications that simply need large resolutions. And so there's that use case. There's the air traffic control system. There's also the use case of all the users of an application being in the same room. What is the purpose of a browser-based system in that scenario? And again, in the case of air traffic control systems, you often have those systems being curated by. I've been to a couple of those situations. You have a group of developers beneath the air traffic control tower, creating the software that is used by the air traffic controllers in that same tower, creating the software specifically for that subset of users. So there's really, and you could say, well, this is niche. This is not, mainstream software. But there are so many of these niches that if you add them all up together, then that's a really large segment of software that really needs large resolutions. That doesn't need the browser. That you have all the power and the not all the authentication and networking problems that you have with the browser and so on. You can avoid those by simply staying on the desktop. So, however, what you find nonetheless, despite that, is that the management of those developers are pushing for that software to be in the browser, despite the fact that A, the air traffic controllers are not asking for it, and B, the developers think it's a stupid idea. So, I would recommend, therefore, tip 1A, consider supplementing the existing system with new devices. So rather than going ahead and rewriting software that has no place in the browser to being in the browser, supplement that software system, keep that system as it is, but supplement it with a mobile app for urgent notifications to those in the air traffic control system, for example, that need to be notified of that, and supplement that system with a web app for management to get reports and status overviews and so on, and leave the remainder of the system exactly where it is on the desktop where it's fine. So that will be very quickly tip number 1. Tip number 2, HTML is actually completely different to what you might have thought it was. And it's a time for rediscovery. And of course, most people would know that HTML5 brings multimedia and audio and those kinds of additions to the browser. Originally HTML as a markup language for scientific documents, and now increasingly with multimedia and audio and video and so on, providing support for that natively from within HTML. But there is much more to HTML5 than that. And I've been exploring that a little bit. So there's semantic markup, there are new input types, there's in fact code completion in IntelliSense built in natively into HTML, and there's even validation built into HTML natively. So my second tip would be to take a look at HTML again, at what it provides. So the basic principles of HTML5 are these. So importantly, of course, device independence. The fact that each component within HTML should be not based on plugins anymore, in principle, like Flash, but based on HTML, CSS, and JavaScript themselves. A very clear example of this is here. This is a plain, normal, standard HTML component, an input element, as we always knew an input element to be, with type set to text. But you can see there that there is an attribute, a new attribute in HTML5 called list. And below that you see a new HTML element called data list, which has its ID set to the same value as the attribute assigned to list. And inside of that there are options, and those options populate this dropdown. And built into this is filtering. So as you type, automatically the component filters based on the options that you've provided. So, I mean, this is one of several really interesting and cool HTML components, meaning that for a lot of things you don't really need to use jQuery and so on anymore. So I'll show you a couple of examples of that. Let me start with a data list, as I mentioned. And this is slightly more complex than you saw on the slide. If I run this into the browser, here's the browser, and here is the development environment. So here you can see this country, and you can see here that we have that list of options with the values, and you can type something in here, and you can see immediately the drop-down appears. You can type something in here, and you can see that automatically the filtering is built in, and we can select something and use JavaScript to display that. But the component itself is pure HTML. And there's actually a lot more to HTML than just this. So let's pop this guy out. Let's remove all of this. And instead of this whole list here, let's put in here a calendar. So everyone needs a calendar component, and everyone's using jQuery for that. But did you know that that is just built natively into HTML with conditions built in? So you can see here that here there's a date. Again, we have an input element, but the type is set to date. And there's also a type email, and there's a type URL. There's all kinds of new types that are built in with, in this case, using a step of 7. And here's the minimum date. It can be selected, but a step of 7 entails that we can only select on a Monday and not on the other days. So that's a date, and here there's a time. And again, there's a step here of which comes down to 15 minutes, and starting from 9 and ending at 5. And no other date can be selected, or no other time can be selected than that. So you can see that the increments, so here are the increments, are in 15s. And here there is a week calendar. So, and this is what fascinates me is that this is all simple, plain and simple HTML that one wouldn't have expected before. There are many similar ones that are kind of interesting in that sense, that they are useful for larger applications. And so you could really treat HTML5 as an application framework. Maybe not this one, but a range, for example. So look in the browser. So here we can choose along the slider a range, which is, again, a native part of HTML, supported by all the browsers, since all browsers are now HTML5 compliant. So that would be my second tip. Take a look again at HTML and at the application type components that it provides. The third tip is focused on CSS. And so I've done some demos. CSS, again, had an original purpose, and you can actually compare what it provides in CSS3 that everyone knows about, the media queries, although the media queries is only one of the many modules that is part of CSS3. CSS3 is now a modular specification, and each of the parts of that specification are at different stages. The media query module is the one that is most known and enables you to tailor a application to the resolution in which it's being run. But you should take a look at JavaScript alternatives to that. And the reason for that is that what CSS3 media queries do is they show and hide elements in the DOM, and this is the key difference. While with JavaScript libraries, you can load and unload elements from the DOM. And of course, this has advantages because you think that you are not loading something when you're using CSS3 media queries, but in fact, you're simply hiding things from the DOM. A case in point is here, this little application. And here it is in full size. We imagine we're creating an application for Coca-Cola. We have here 2 different logos. And if I make the application portrait sized, you can see that they both disappear. And let's inspect that and what's going on there. And we'll see that there's an interesting difference between those 2 logos, or why we might choose one approach rather than the other one. And inspect in NetBeans mode. We take a look. We make this large. I select this one, and we can see here that this is the CSS being used. So we're going to the source here, and here we can see that this is the CSS class being used in that particular case. The other one is this one. Okay, so here's the second one. So there are 2 different classes at play here. Now, if we make the resolution small, and they both disappear, we see that one of them is still there, while the other one has vanished. So one is shown or hidden, and the other one is loaded or unloaded. So here they are both again, logo 1 and logo 2 in the bottom left. And when the resolution goes small again, only logo 1 remains. And this is not ideal, especially if you can use an approach where you don't have the show and hide mechanism, but a load and unload mechanism. So how does logo 1 work? We take a look at the related class. And here is logo 1. Oh, there it was. Let's go back to it. Okay. So here is logo 1. And you can see here it uses media queries. So if the minimum width is this, then show the logo. And if not, then don't show the logo. Logo 2, on the other hand, works completely differently. It makes use of something called, of a library called response. So here I have it in the browser. Response.js, open source library, you can use it, include it in your application. And what it enables us to do is to set breakpoints. So you can say, here are the 3 breakpoints, 0, 4, 80, 4, 81. And here they are in use. So if so this response creates, and these breakpoints that you see here come from the response library. And so we can set breakpoints, and based on the particular breakpoint that is set, we can change a variable, and based on that, we can either show or hide whatever we want to show or hide. A third approach, which is comparable to Response.js, is provided by something called Foundation Interchange. Also a really useful library. Foundation Interchange, you can see here this example 3, and where it is used in the application, where is it now? Here it is you can see here, here in there's a text, you're using a medium resolution. And now you can see it says using a small resolution. And these come from what are called fragments in Foundation Interchange. And again, there are breakpoints, small, medium, and large, defined by Foundation Interchange. And if it is small, then we will use an HTML file called small HTML. If larger, then medium, etc. And there is simply an HTML file, in this case, that has each of those texts, using a larger resolution, smaller resolution, and so on. So if you think CSS3 is great for its media queries, you're right. But JavaScript probably offers you more useful techniques and idioms to use. So response and Foundation Interchange. And I've done some demos. So the fourth tip would be evaluate 2 different approaches when you're choosing the libraries and the components that make up your stack on top of which you base your application. There's just a massive amount of libraries and frameworks, etc. out there, as we all know, and this is the biggest problem that we all have. On the one hand, it's great, especially from a Java background, to have so much innovation, and every other week there's a new library, which is wonderful, but the week after that, that same library is no longer there because the people working on it got bored and are doing something different, because it's a very exciting space and you're constantly learning, and it's all very great. But of course, if you're creating enterprise applications, you want them to last a bit longer than until the next couple of weeks. You want them to be there certainly for the next couple of years. So how do you choose the right libraries as the basis of your application? And what people typically are doing nowadays, as I'm sure everyone knows, is simply taking Angular as your application framework and taking that as a stack on top of which you create your application. However, I would recommend as a tip, before you do that, find as many of the libraries that are out there, categorize them like this, something similar to this. Don't go to Indeed.com or Jobs.com or all those different sites. Don't throw in there all these different libraries and compare them on that basis, because I've found that completely misleading. What you get from that is more what people have searched on rather than what people are actually using. Just because everyone has searched for a particular library, they might have researched that library and ended up not using it. So all those different comparison devices in terms of Indeed.com and Jobs.com and all those different things, I don't think they mean all that much. But they do provide pretty graphs. So the one approach would be the framework approach. It's definitely quite safe to take a complete application framework and go ahead with that, except, of course, as anyone knows, within the Angular world, there's now the shift from Angular 1.3 and 4 to Angular 2, where Angular 2 is a completely new framework, and it's not that compatible. So that's kind of a kind of place where you can get really stuck with that approach. As well, you might only want certain parts of the framework, but because you've taken a framework approach, you have to buy into the whole of it, because it comes with everything included, which can be nice, but can be a problem as well. So the library approach would be to take a bunch of available libraries and combine them together in a best practices approach. So either one of these, both of them have several problems. The library approach being definitely more flexible. The framework approach having advantages too. And right now, there are lots of books being written, for example, on Angular 2. So there's definitely innovation and stabilization going on around that framework. But consider those different options.
Tip number 5, look at modularity. So you're creating a slightly larger application. Of course, you're not creating an air traffic control system. I've not heard yet of complete air traffic control systems in JavaScript and want to fly with that particular airline either. But modularity is a good thing. JavaScript natively right now doesn't have that yet. It's coming in ECMAScript 6. If you're creating enterprise applications, probably you're not doing cutting-edge development. You want to take some libraries that are quite stable and usable already. So you're not going to be able to benefit from ECMAScript 6 immediately if you're in the enterprise. Therefore, take a look at the different modularity solutions that are out there. So here, kind of separation of concerns, communication mechanism concept. There are various libraries out there. There's Require, there's Browserify, which are the most popular ones outside the Angular ecosystem. Within the Angular ecosystem, System.js is the one that is incorporated into Angular 2. And then once, as an enterprise, you're ready for it, you find that by that point, ECMAScript 6 will be more stable than it is right now, and you could use that. I want to very briefly look at Require, and I'm going to do that using some very small examples. First, we take a very simple sales system, and it is so simple. Just to prove a point, we have 4 JavaScript files. We have an index file. You can see that these 4 JavaScript files are loaded in the index file. And first of all, authenticator is loaded. I wouldn't recommend this authentication system. If the name that enters is longer than 1 character, you're authenticated. But it's an example. There is a buyer. A name comes in. Authentication is done. And if authentication succeeds, something is sent to this person, and if not, an apology is sent. We're simulating this. Everything is printed out into the console. The starting point here is main.js. And in main.js, there's a name hard-coded, printed to the console, and then that name enters into this really fancy sales system. What we see in the console is exactly what we would expect. So the person enters the system, they try to buy, and so on. If the name is less than 1, so 0, you can see that the sale fails because authentication fails. So what would happen if these files were loaded in a different order? So let's load main slightly higher up in this list. So I take main, I put it up there, and now the whole system crashes because that is an actual load order. So first authenticator is loaded, then main is loaded, and in main we refer to buyer, but buyer isn't there, so the system crashes. Now this is a very simple, small application. In reality, of course, you have hundreds of JavaScript files that you're loading into your application, and you would have to manage that load order yourself, which is next to impossible. As well, you're loading everything via the index file. And in reality, you probably want to load some things on the mobile device and some other things on the desktop browser, and not everything at the same time in the index file. So what Require gives us is some very nice idioms to solve this problem. In the index file here, I am not loading 4 JavaScript files. So here is a modularized version of that exact same system. It does exactly the same thing. But the difference is, so here I'm loading 4 JavaScript files, and in my new system, I'm loading 1. And that 1 JavaScript file is RequireJS itself. So what we're doing here is we're delegating the loading to Require. And there is an attribute here which is defined by Require, data main. This is a RequireJS specific attribute. And we are providing here an entry point into the application. Now compare this to the original main. And we can see that in the original one, we just had 4 statements. And here we have 4 statements wrapped in the terminology of Require, wrapped in a Require block, which is equivalent to, in the Java world, a public static void main. So there's 1 Require block in the entire application that uses Require, and all of the other JavaScript files are wrapped in what are called define blocks. So every JavaScript file except the entry point are in define blocks, and here we can specify what Require should find for us. So we can provide a configuration file which Require will use to look for authenticator and thing. In this case, they're all in the same folder, so we don't have to do that. And then we can refer to them using that callback function in the same order in which we loaded them. The name doesn't have to be the same, but the order is important here. So via this mechanism, we don't have to think about the load order in the first place, and in the second place, we can specify when something should be loaded by require. So that's a very nice idiom as well for larger applications. Tip number next. Tip number 6. Okay, very quickly. You don't have to write in JavaScript, CSS, and HTML. There are preprocessors and postprocessors. There are abstractions over those base techniques. Emmet, very useful, can type very small snippets and generate from that snippet a complete set of HTML. TypeScript, of course, very popular right now, also because it integrates closely with Angular 2. CoffeeScript, very space-based, tab-based layer on top of JavaScript. Sass stands for super awesome style sheet, and less for something as well. And these are postprocessors for CSS, so that you don't have to type in native CSS or in native JavaScript if you don't want to do that. Okay, and here is the big elephant in the room. Don't worry about ecosystem volatility. You know, the kinds of applications being written here are not Defense Force large mission-critical systems. These are kind of smallish systems. One could describe them as the lifespan of your app equals the lifespan of the framework that you're using, or the particular release of the framework that you're using. And what often happens is that rather than adding new features to the existing system, when new feature requests come in, is that by the time you get them, you're 6 months older, and you can create the application from scratch again using the newest libraries, the newest versions, and so on available. The consequences of this are that you often end up with a rather hard-to-read code, and people don't worry so much about maintainability because you know that down the line this application will be thrown away, which brings us to the and so this is the tip here. Don't worry. I mean, if this is a worrisome thing, then this is not the right ecosystem for your software. That's kind of the way it is. Which brings us to this mysterious Wanta, which it turns out is closely related to this picture and stands for write once, never touch again, which is not a bad thing if your software fits into that particular bracket of that subset of software systems. 2 more points, 2 more tips. This one is really interesting. Evaluate corporate frameworks. It's really an indicator of the maturity of the JavaScript ecosystem that large corporates that you wouldn't expect are actually playing a role in it. So this morning there was a session by Microsoft with all their various open source stories, including JavaScript, IBM, Salesforce. Very interesting one, ING. They made a big splash about this at DevOps in Antwerp about 2 or 3 years ago. Spectacular. Made a big splash about it, keynote, etc. Since then, I haven't heard much of it. I've tried to get in touch with the people who did that session at DevOps 2 or 3 years ago. Haven't heard back from them. GitHub repo doesn't seem very active. But if you want your applications to look similar to the ING online apps, they have very specific components and coloring and styles, then this is one way to go, assuming that it doesn't look as dead as it appears to be. I was at a conference recently in India, and there was a VP from PayPal who did the keynote session there. And I thought, what does PayPal have to say to software developers? And it turns out that at PayPal, they're developing a Node.js and Express-based framework. They've been developing this internally for some years already, and they've made this open source. So if you go to KrakenJS, krakenjs.com, you'll find that this is there, and you can see right in the top here, PayPal open source. And also Douglas Crockford, one of the main guys behind the whole JavaScript ecosystem, works for PayPal. So there's a lot going on with PayPal, and they're working with, they've open sourced their solutions, at least the Node.js Express stuff that they've been doing internally. The other one here, I'm quite involved with this, Oracle Jet. And there is a homepage, and the idea here is very similar to the PayPal one. So this, just like the PayPal story, is a solution that's been created within Oracle over the past years and has been open sourced. If you go to github.com, and to Oracle. So actually, Oracle is on GitHub, not just with Jet. There's actually a bunch of stuff that you find by Oracle on GitHub. But there's also a repository here for Jet. And what Jet is a bunch of components that are used in applications that Oracle is creating for working with data in the cloud. This morning there was one that I saw, and I made a picture of it. We'll come back to this in a second. Here, so this morning there was a session about Oracle's IoT cloud service, and the application is clearly using a bunch of graphs and charts. And these are the graphs and charts that are part of this Oracle Jet solution. And they are these. So these are created in jQuery UI by Oracle. They're open source. You can use them in your own applications. There's a very liberal license for using these in production. It's been used a lot internally by Oracle since about 3 years. In that sense, it's stable. It's not new. It's not been thrown over the wall yesterday. It's focused on not being a framework like Angular and not being a library, so it's not OracleJet.js. It's a toolkit. It's a collection of open source libraries. And the libraries I pointed to earlier are actually the libraries that are the basis of Jet. So jQuery, jQuery UI for components, jQuery for Ajax and JSON calls, Knockout for data bindings, and Require is the module system. And it's used in a lot of different applications within, and increasingly also being explored carefully outside Oracle. So here are some of these applications. And actually there are quite some other ones too. And I'm here in London to be at this conference, but also to visit some customers who are interested in this approach as well. So it is a collection of open source libraries. It's free and open source. It's a specific architecture, and there are ideas built into it about accessibility and modularity and so on. A final tip would be to look at JavaScript in a different way. Look at JavaScript as assembly language. So here is assembly language, and then you would think, okay, so what's the connection between this and JavaScript? So, okay, here's JavaScript again. Okay, now this is JavaScript, right? So to me, it looks like not something I would want to be coding myself directly, except if you are really into JavaScript. This is not my language of choice. If you go to this link on GitHub, you will see that there is a massive amount of transpilers available that can be used within, let's see if I can get there. Oh, wait. So if we just go to Google, and not Maps, and look for transpilers, JavaScript, you will see that here, list of languages that compile to JavaScript, which, I mean, in itself is an indicator. There are just everything can compile to JavaScript. An indicator of how popular the JavaScript ecosystem is, probably mostly, if not only because JavaScript is the native language of the browser. So whatever language you have, you can compile it back down to, or you can compile it down to JavaScript. In the Java world, of course, Grit is very popular in this space, and Vaadin, Vaadin.com, Vaadin as the GUI toolkit on top of Grit, also very popular. I want to briefly talk about something else in the same area called DukeScript, because it's probably less well known than Vaadin. So just to give it some attention, if you go to DukeScript.com, this is a technology comparable to Vaadin in the sense that you code your application in Java, and it magically compiles this down to JavaScript, but it does more than that. You can also use this to create Android, iOS apps, desktop apps. It uses JavaFX as the view technology, and inside of that, it puts the JavaScript that it generates. And using Dalvik, using RoboVM, it creates a native application for either Android or iOS. The nice thing also in comparison to Vaadin is that where in Vaadin you traditionally write your view and your business logic in Java, in DukeScript you write your view in HTML and your business logic in Java, enabling you to hand off the HTML to a designer to work on while you work on the business logic. And that kind of separation is also very nice. And there are Maven archetypes that you can use to set up these applications. And they have built-in Maven goals, Maven plugins that compile that down to either JavaScript if you want to run it in the browser, or iOS or Android or whatever. So you should see DukeScript as really being a toolkit or a framework of different technologies for creating applications for Android or iOS or whatever your endpoint is. And it definitely offers solutions that are preferable to Vaadin for the reason that you can separate out the HTML. So I guess here we are, and there is even time left. So I would say the building blocks of larger enterprise applications in the JavaScript ecosystem are, in the first place, to, if you can, avoid that move unless it's really needed within the context of the users of the software system that you're working on, and secondly, to really take a look at HTML5 anew. And don't only look at the multimedia stuff and the audio and whatever, but look at the application framework type components and solutions that are now built into it. The third place, I think this is maybe the most practical and useful thing, and kind of disappointing for the whole CSS3 ecosystem, since probably the most well-known part of CSS3 is its media queries, but really look at the JavaScript alternatives, because you can avoid this process of downloading stuff and hiding it and showing it and whatever, because you've still gone to the trouble within the application, within the battery life and the networking, etc., of downloading stuff that you don't actually need. In the case of the JavaScript solutions, what happens automatically is that DOM elements are added or removed based on the breakpoints that the JavaScript library provides. The fourth point, don't necessarily run after the Angular bandwagon. It's very clear that there are dangers with that particular approach, and there are a bunch of alternatives out there. There's a whole bunch of libraries that you can combine, and the Oracle approach I think is quite a sensible one, to build it on top of a ready-made toolkit, which is what Jet provides. Anyone can build their application on top of that combination of technologies. The other point, really think about modularity, and you can really bring that in even without ECMAScript 6 being ready and usable yet. It's already built into a bunch of libraries. You can use that already. You don't have to use JavaScript, CSS, and HTML natively. You can use those things on top of it. Don't worry about this being a volatile space, except if that is a problem for your software, then this is the wrong place for it. Write once, never touch again. If that makes sense for your software, then this is good. And there are a lot of corporate frameworks out there, and corporations are coming out with more and more JavaScript-based solutions, which really is interesting and shows that it's a pretty mature ecosystem now. And somebody pointed out to me that if even Oracle is doing things with JavaScript, it probably means that JavaScript is on its way out. I wouldn't go that far, but Oracle is in that particular space as well. And you can avoid JavaScript as a language altogether. Even though the browser requires JavaScript, you don't have to write in JavaScript if you don't want to. Thank you very much for attending.